Okay, so what we have here on the left is a weighed out sample of our copper complex, the unknown complex. And on the right is a weighed out sample of the copper sulfate pentahydrate. This happens to be the same chemical we used as one of the reactants. And what we're working on here is the percent of copper in the complex. That data has been copied onto a data sheet. Notice the people doing the experiment, your name, your partner's name, and the date. And now Mrs. Syak is going to use these two samples to make up a solution, two solutions, one of the unknown in water and one of the known copper sulfate pentahydrate also in water, but both will have ammonia added to them. So she's going to add 15 mils of ammonia to each solution. And that's the first step in figuring out the percent copper in the complex. Take it away.
Okay, so the first thing you want to do is make sure that you know the unknown is labeled and the copper sulfate's labeled. You might say, why did we use copper sulfate? It's blue, that's why. And so is our unknown. So the first thing we want to do is you want to make a solution. I'll make it with the unknown first. And we have to carefully transfer.
Make it on this side.
We have to carefully transfer the unknown to
Wow.
the volumetric flask. Now we don't want to drop any, so it has to be very patient with you. You have to be very patient. Did a good job.
Good job.
Now, see, there's still some in there. So as usual, I use a little water.
This is called a quantitative transfer.
Okay, and so what I'm doing is I have to put water here anyhow. So I'm going to try to rinse all the blue out. And you'll notice I did a pretty good job. So, am I perfect? No, but now I've got my material, my crystals here. I'm going to swirl them around a little bit, maybe put my hand down there. And when I make a solution quantitatively like this, you remember that there's a little marker where you can see on these volumetric flasks. The volumetric flask is marked to that point. You can barely see it.
Where's the mark?
It's right here, right here.
Okay.
Okay, that's kind of hard to see. But when I fill this with water up to that mark, and the meniscus rests on that mark, I will have exactly 100 milliliters. I think you probably have seen this. So I'm going to add a bit of water. And the other thing I have to add to this, according to the directions here, it says to add 15 milliliters of a 6 molar ammonia solution. Again, read your bottle. This says NH3 ammonia, also says ammonia, 15 milliliters. So I need a small...
Oh, just use this one.
I'm going to use this. Oh, yeah, I'll use that one.
I rinsed it.
Okay, great. So I can get 15 milliliters in here. So the one thing I don't want to do is put too much liquid in the volumetric flask too quickly. So let me see. Oh my gosh, it's only perfect.
Good.
There you go. I'm going to close it up. So both solutions are going to be made the same way. And I'm going to carefully, again, pour this in. You'll notice the color changed. Now, the volume of this isn't really critical to this, but the volume in here is critical. So now I'm going to add a little bit more water, and I'm going to swirl it around a little bit. I'll look for solids on the bottom. It looks pretty good. And I'm going to add water up to the top. Now, this is nice, but one little slip and too much water. I got to throw this away and start again. So I'll add a bit here until I get close to the neck. And be very careful. And let me see, I have a dropper bottle also with distilled water, and I'm gonna use that to finish it off. Now, my eye has to be right at the level of that mark, so I'm gonna try to be careful here. And some bubbles. Oh, only perfect.
Hold it up, let's see if we can get a close-up. I'm not good at this.
It's kind of hard to see. So it should be resting right on top of that mark that's on the flask.
All right, not bad.
Now what I'm going to do, I'm going to invert it 10 times. I see a little bit of the solid on the bottom, so I want everything to be dissolved. Again, if you see solid and you're trying to make a solution, that solid that's not dissolved is not going to, this seems to be a little.
We're gonna let it sit a while
Yeah, I think
anyway.
we should let it sit. Okay, well, I'm gonna let it sit now. And there was a little bit of solid here, and it is dissolving, so we're doing okay.
All right, let's work on the next one.
So the next one is done exactly the same way. I'm afraid I made this all wet, but
Doesn't matter,
when you do
that's-
chemistry, everything gets wet. I always say your papers have a little more character. So let's try that again. I'm gonna try to put this in carefully so I don't lose any, because this was measured, and measurement is meaningful.
Good job.
All right, there's nothing left in here, but I'm going to give it a little squirt. All right, it says to add a little water first. Okay, let's roll it down. 15 milliliters of ammonia, again, the same preparation. Again, you control what it says. And the more you do this, the better you get at it, so not to worry. I can smell that ammonia.
Although I can't through the mask quite as easily.
I'm close to it, that's why.
Yeah, I know. It's that
All
old
right, now.
diffusion.
I'll swirl it around a little bit. These particles were much smaller. And I'm going to, again, put some water in it until I get to the bottom of the neck. Again, don't be in a hurry. You can't take it away. And I'm going to add, where's my distilled water dropper bottle? I'm gonna add a little droppers of water. Let's see. I think that will do. I think that will do. All right, so now, again, I'm going to invert it. I see a little bit of solid at the bottom. So we're going to let these sit for a few minutes. Remember, the solid at the bottom will not be reacting, so will not be in solution, so it will throw off your experiment. Now, if we're talking about making errors and how they can affect your results, this is a big one. Number one, maybe all your solid wasn't dissolved. And number two, maybe your solution wasn't exactly right, and that will affect your results.
Hi. So we have basically got our two solutions, the unknown and the copper sulfate solution. which we call the standard solution, because we know we're going to be able to calculate its concentration very easily. And so basically when these solutions are prepared, all of the copper in each of the solutions, whether it's from the unknown in one or the copper sulfate in the other, all of that copper reacts with the ammonia that was added and forms a different compound, which we also call a complex, an ammonia complex. And the ammonia complex has a very distinctive absorption at 600 or so nanometers. So we're going to measure the absorbance of both of these solutions at 600 nanometers. So I'm going to use a Spec 20 to do this. So first, did we zero it? Let's zero it again, just to make sure.
Okay, I think it's in here.
Oh,
actually.
okay.
Okay,
So just leave it in
So,
there. We'll
yep.
hit the zero.
all right.
Can it even see this thing?
Now we use a wavelength of red to go through a blue solution,
Yep.
which is when it gets its maximum value of A.
So the absorbance of the unknown. Let me get that camera over here. Not sure we can do this, but I will try.
972.
Yeah, 0.972. And for the standard, the copper sulfate pentahydrate, the absorbance was 0.597, but we have edited out a little mishap that you don't need to see. And so we're going to use this information to get the percent copper. And just to show you how we recorded these absorbances on our data sheet for the percent copper, see it has the masses there, so we can calculate the concentration of the standard. And so here's the absorbance of the unknown, the 972, and the absorbance of the standard. Okay.